Let's look at the needs-driven workflow design for geospatial visualizations. Using the general workflow introduced in Unit 1, we will look at the types of data that are used to generate geospatial maps, the types of analysis, and also the visualization of geospatial visualizations, comprising the selection of the visualization type, here the selection of the base map, then the overlay of data, and then how to visually encode the data. Ultimately, via deployment, it becomes possible to validate and interpret the resulting visualizations, which then oftentimes leads to more data acquisition, more analysis, better visualizations. So here, in this particular example, you might have a geospatial map of the US. You might have a proportional symbol encoding of data. So here you would first of all identify the geolocations of your data points and then use color and area size coding, for instance, to generate a proportional symbol map. In terms of data, there are a number of free data sources and you might like to explore them. You might also like to apply some of the workflows you learn in the hands-on sessions to some of this data. In general, there are different types of data formats. There are vector formats like shapefiles, there are raster formats. Some data sets also come as tabular data, as CSV file, for instance, where one column might be an address or a zip code, etc. And then there are many software-specific formats, and many of them are proprietary. Pre-processing data often involves thresholding, unification, the also gazetteers, and aggregation. And there's an entire session on how to aggregate geospatial data. So here we will use an example of mapping the diffusion of information among major US research institutions. So here we had to find out if we actually maintain the geographic identity of the different campuses of IU. So IU has 8 different campuses spread throughout the state of Indiana. And it was interesting to decide if IU now should be represented as one data point or if it should be represented as 8. And actually IU Bloomington also has 2 different zip codes. So even the Bloomington campus could have been represented by 2 zip codes. So it's interesting to find a compromise between geographic identity and statistical significance. And it has implications. So if you now represent each campus according to geolocation, so you end up with 8 instances of Indiana University, then potentially IU doesn't make it into some of the top 10 or top N lists. Whereas if you treat it as one instance and aggregate all the student numbers, all the student income, etc., over just Indiana University, then it might be big enough to make some top N lists. So these are very important decisions, and there are no general rules for this. I think it has to be decided based on the questions that your client or that you have. And if you want to learn more about how we decided it, feel free to follow up using that paper given here. In general, if you have linkages in your data set, then you have to make sure that no link is longer than the Earth's circumference divided by 2, because it couldn't be longer. So it's very important to do these data checks. And down here in the example, you have the airline route between San Francisco and Tokyo as a great circle in red. And we already had that as part of the terminology part. And as part of the jet stream in green when heading eastwards. So if you fly in an airplane, it would probably use the jet stream route. Now let's look at some visualizations. The subsequent slides show a map of the US with different overlays. One is a choroplast map of unemployment data in 2008. Then I will show you a proportional symbol overlay of using the same base map, and that overlay is of airport traffic data. And then you will also see linkage overlays. So this is our base map. This is US unemployment at the county level. And what's missing here is a legend which indicates what darkness of blue in this case represents what severity in unemployment. This is as proportional symbol map which shows different airports in the US. And if you look at South Bend Regional here in 2008, you see all connections that you can make from South Bend. If you compare this with the Chicago O'Hare International Airport, then you see major differences. So that, first of all, this is an international airport, so there are actually lines going outside of the US, and then also just the immense number of flight connections you can make out of O'Hare is very different. In terms of relevant tools, there's a lot of open software. Obviously, there's also GIS and other commercial systems, but then there are also software libraries like D3, which you can use to design new visualizations. And if you have links to other tools, or you would like to point us to other geospatial visualizations that you found interesting and meaningful to your decision making, please post them using Twitter and Flickr and the tags IV MOOC and GeoTools.